All right, looks like we're live again, so that's good. Let's pop over to the app, which is always very handy. There we go, good. All right, cool. So let's then pop open Vim. I believe that we're on the, nope, we're not. All right, now we are on the right branch. We delete some old branches here. Oh, all right, nice. So today we are going to try to, we're starting the process of collapsing free monads into just tagless final structure. So the, let me actually make sure this is still recording. Yeah, it is good. Okay, good. So the main thing is we've got a bunch of files in perp.scala. No, we don't. Yeah, so we've got core term interp and then a bunch of these generators. These are all just interpreters for free monadic, they're the free monadic interpreters. So if we look at, let's say, HTTP client generator, this thing is an interp that extends, oh, that's not what I wanted. All right, let's try this one more time. Gonna launch the JVM this time because otherwise we don't get type hints. Let's do it again. So we've got function K from client term based on the Scala language to target. Function K is a function on the surrounding structure. So if we look at apply for function K would look like function K apply would take an A, an F, and a G, and for some instances you would be able to say like FA is F of A, and then this will just return G of A, right? So the whole point of this is to be able to turn a client term based on Scala language into an actual structure. Think of this as more like a promise of work to be done in the future, and then this is actually the result of doing the work. So this is effectively exactly, we can actually find the apply function here, sure enough, look at that. So apply T, considering that F is here and G is here, target accepts one type, this question mark is one type, so we've got the type constructor represented there as well, and we look at the apply, and now we actually supply a real type for T in both cases, and then we actually just make sure that we do the work. So makes sense, but because the way that free ends up working, it ends up creating a lot of garbage, like in the JVM sense of garbage. So if we look at package.scala, those who have worked with free monads before may be surprised to see that we actually have quite a number of nested interpreters here. This has worked relatively well, but it's been slow for a while and it's not going to get any faster. So the motivation is to collapse these all back down into effectively straight function calls that are bounded by some other type. So bounded by the type constructor for whatever their interpreter is implemented against. So very similar to how we are implementing client term to target here. What we would end up with is something like client term TF, F this with say some do work. I guess A would be, actually we could just do like long, and then this would be f of long. And so we would leave the definition for that unspecified, but then if we needed to implement something that, like a function that needed that, we would just say do more work, right? So just f, and then if I have, let's just pretend that I have a function, or I have a value long, and I want to produce an f of long. But I don't know how to create one of those things, but I want to use this do work. What I can do is I can say implicit of plant term tf f, and now I have this ev, and I can actually say ev dot do work 5l. That satisfies the needs of this function signature, and also because we're deferring the type of f until the call site of this thing, we can't just do random other things. Like I can't choose my f. I'm still bound by whatever terms are available for this implicit, right? So I have to actually supply all those things. So we can actually see very similar the representation of this in the free monad structure. So for awk HTTP, I want to change an entire codegen application to an entire target. And so I actually have to stack all these interpreters together all the way down until we get to the end. And then we just say, okay, just here, apply based on whatever your input is going to be, apply that. And then give me back a target of that type, which is fine. What I'm trying to say, though, is that this client term interp just lives here. So it's not implicit in this case. What is implicit is being able to actually emit a client terms. So we can actually look at client terms. So there's a little bit of terminology here, but the way that you use these things is you actually just say, I'm going to take a client terms, I'm going to do some work with it, and then I'm going to emit. In this case, it's all constrained by free, but I think that we can actually do, maybe not completely without needless boilerplate change, but I think that we can get really close to sort of chunked refactors without doing like a whole boil the ocean approach. So the same thing of like just importing all the terms from this client terms thing. Same with framework terms and whatever. What we want to do is we just want to supply a different structure that has this same format. There's one aspect that I don't understand as I'm realizing that I'm talking about this, which is that I don't know how, because these are all implementing, yeah, so I don't know how, what I was going to say is I don't know how the flat map is going to work for all of these. I'm realizing that what we would have to do for all of these cases is just make sure that we have a f __ monad error in scope as well. F is coming from up here, so yeah, we can just tack on, this is going to suck, I think. So if we tack on that monad, because we're changing free in all of these call sites, we're changing this free into F clients L, or whatever the type actually is. We're actually collapsing down that free. We actually have to ensure that we can do monadic operations on it. So somewhat unpleasant, but we'll make it through, I think. If I knew Scalafix, I think this could actually be all just done via a Scala fix rule and just rewrite the whole code base all in one big action, but I don't know Scala fix. So let's get everything set up here. Oh, I need to reload. Yeah. All right. So if we, let's start with, if we look at the package.scala, so my thinking is if we start, actually I don't even know if logger is still used. This should have gotten merged. Ooh, it should have been deleted in the last PR. Okay. Oh, and these tests can be re-enabled. Oh, great. All right, cool. What do you know? So get rid of that. Let's run those tests. That was from yesterday's stream. Just didn't see those. I'm sure there's going to be more stuff like that, where because those logs have been disabled for some time, we're probably going to continue to find more stuff like that that's just been commented out. But what we can do is we can say this is in the CodeGen module. So if we say CodeGen test only core.structured logger sweeps, so we can test that out. Even better, getting rid of imports. Love it. Value is not a member of, sure enough, you're right. 21. All right, so structure, value, structure. So this, why is the value? Because this used to be an either t. So that makes sense. Now it's not an either t, now it's just a target. And so target actually has log entries just built in. So we can actually cancel that, rerun. So this will actually probably just work. Then structured logger, sure enough, not actually used. One thing that's been bugging me is Twilio Swagger. Looks like structured logger is the only thing in Twilio Swagger core, so that should move as well. So we can do that. Pretty good at the very least that this is compiling, so that's exciting. Yeah, so this test just tests that the log which wraps this whole thing. So first function wrapper, second function wrapper, and then 3 logs inside. That should actually be structured like this, where first and second are both very clearly nested. They're structured. So there's a mode that this can operate in where only the first one of a certain depth is emitted. But I think I have that commented out right now globally. So right now it just emits everything, which is useful as we add more log wrappers to everything. It's going to be useful to have that in the interim. So yeah, compiled, so that's good. That. do this for completeness and consistency. Okay, so that, and then re-enable. Okay, good. So, let's, as we were mentioning, starting at, I want to say starting at the edge and then working down might be easiest. Implementing Scala terms. So what? Actually, I don't think there's any easy here at all, because this is just everything depends on instances of every other thing. So any of these can depend on instances of something else in the stack. So framework CS can depend on like codegen application because it's depending on Scala term, the Scala term instance. So all that is to say, I don't think this actually matters what one we start with. But just to make things a little bit easy, I think we're going to start with Scala term. Scala, no, core term interp. Actually, core term interp might actually be the easiest one because that one's isolated. So core term interp, we can look here. These are the only terms that are defined in core term interp. So we can just kind of get rid of this. So it should be straightforward. What we can do, we're trying to prove that we can inject core term into F, whatever F is. Let's check to see where core terms is actually used. Core term. That's to get one of these things. But we're just injecting core term. Yeah, we're injecting core term L question mark into itself. So we're actually just doing these. This is effectively identity, where the implementation of this thing, we're bypassing in core term L for F. We're just trying to inject K core term into itself, which is just going to give us back the same thing. So this is actually safe to go away. If we change these, let's F just to F bracket, right? Should probably just work. Core term doesn't need an inject anymore. Now core term for F. This doesn't need, so core terms, it's not going to be free inject. This is going to be, I think this is going to be like this. I'm just sort of making this up because I've forgotten what the structure, I'm not really copy pasting this, I'm just sort of going based on what I think that the thing should look like. It's been a while since I've actually looked at a free or a tagless final tutorial, so I'm pretty sure that this is going to get us close-ish. The one thing that I'm somewhat concerned about is making sure that we have a monad instance available for some of the work that we're going to try and do. So I don't want to have to tag f with monad everywhere. But we should be able to see, as we write this thing, what this ends up turning into. So now that we have this core term, we can actually just implicit have core terms lf, and then just return. And so instead of creating a new one, we are just going to return the one that we found. So again, this, let's look to see what core term looks like. Oh, core term interp is over here. Okay, so core term interp, given all of these things, so if this is a class and this extends core term to target, we can instead have this extend core terms L to target. No, L to target. Yeah, right. So we extend core terms L to target. This goes away. Let's actually just comment this out to start, just to see what the compiler errors that we get are. Because I suspect that this is going to be fairly, well, first of all, it's going to have a whole bunch of compiler errors. But should be at least intelligible compiler errors. We also don't need a case class here. I don't know why that was a case class. We can pass that on the second one. So this is extract generator, sure enough, look at that. And so it just wants concrete instances for these things, which is great because we can provide. So let's do this. We are going to nuke that. We're going to nuke that. This is going to dedent. We're going to change all the case that, and then the rest of it. Actually, yeah, all the way to the end. And we're going to change that into def lowercase, I think it's that, 2 equals. Probably. Yeah, okay, good. So we at least got, without too much of a mess, we did, unfortunately, we don't have a way to bring over the argument types. So we may as well just copy them from here. So extract generator. The unfortunate thing is that this is going to be, it's going to come along with a bunch of imports that I don't need. So these are going to be fully qualified types, which I don't want. But the flip side is that maybe we can just grab, yeah, args is, oh, validate args is going to be list of args. Yeah. Parse args is going to just be array of string. Parse args, by the way, a really great function. You should definitely take a look if you're interested. This is arg set. This one. This one. Oh, we can actually just grab these. I just realized. Process arg set is just that to target. This needs a this was missing a curly, and that was legal before because we were inside a flat map. So the fat arrow gave us a little bit more flexibility for scoping. So that should partially compile. 34, vendor default framework. What did I miss? Oh, expect generator. Oh. Render default framework. So that's good. The core term L, diverging implicit expansion for that. Yeah, probably. Let's look at 73 on CLI. What is the type of C? Def C. No, that's not what I want. I want C. Val C. Yeah. No. Core term L, core term L. Oh, this is F. Yeah. So this is not core term L anymore. This is target. This is going to be weird. We may have to cheat and look up on the internet to see whether or not someone has an intelligible explanation of this. Diverging implicit expansion for... I disagree. Terms can just go away. Good. Ooh. Okay. So we've got core terms LF. Core term LLAF. So this should be core terms L target. Core terms L target. Now, why? Why does that not like it? This is a guess, but it's all I have for now. Definitely shouldn't be necessary, but I don't want core term Java interpreting. Wait, hold on. Did I delete the wrong thing? Oh no. Okay. Let's. There's only 9 of these, so it shouldn't be too terrible to just delete them. So this Scala interpreter is going to be a core terms of that bound by target. Bound by target. Same with the interpreter is going to be core terms and target. So core terms and target. What are we? Yeah, so we don't even need C anymore. This is just interpreter. So we can just, I mean, actually that would be a good way to verify. Interpreter. Yep, we got farther, so that's good. Core terms. Run M is going to be different. So this is core terms. Yeah. So C is core terms. It's always going to be the same. Core terms L and F, where F is coming from there. This is now no longer going to return free. This is going to just return F of that. LA and F. Do we even need this target? it's always going to be that. I don't know. But this is the first place that we're going to actually need the monad instances, so we'll see. Core term is still present somewhere. So let's get the rest of that. Core terms. Okay. Go away. Process args. Process args. Common process args. This is process args F. Yeah, I mean, so this is also going to be target. I mean, it can't not be, because it has to just be that. I'm starting to hear squeals in the other room, so I may have to, actually, 1 second, let me warm a bottle. Riveting kitchen sounds, I'm sure. So we've got fold map. So we are not doing a fold map anymore because now in CLI 92 fold map interpreter, so core args is just an F now, it's just target. So parse args really does return target, which means on line 92, we don't fold map on interpreter anymore, we just flat map args on guardrail runner because now it's just target. 164, fold map Java interpreter, core term interp. It's now no longer, wait, so core term interp. Oh, yeah, all right, that makes sense. So if we change these to new, because that was actually where we were using the case class, so we were just avoiding writing new. But because of that, we can actually implicit def these, and then 164, we don't need this anymore. Run m in common. Run m will just take an implicit core terms and we'll just use it and return the values. So because we swapped out the f for target, now fold map goes away. Now these are just run m. Maybe. Just ripping out whole swaths of code. Common flat map is, here we go. So because we don't have the monad instance for f, we have to supply it using type description here. So we've got implicits, we've got import cats monad. I'm explicitly not doing monad error here, although I could by fixing the error type to error. I just don't want to make so many changes. 180, sure enough, yeah, so this is gonna suck everywhere. But just to get it compiling, let's do this. 181, no, I don't care. Ooh. Is really not gonna like places where I use traversable. or fold 194, diverging implicit expansion for order A, Y, LAF, args, F, non-empty, no, I don't like that. That shouldn't be necessary. That sucks. Okay, let's get rid of that right quick. Core terms. So, core terms, we have to have L so that we can dereference the terms inside the language abstraction. We have to have F as well. Wow. I don't want to introduce path-dependent types, so I don't want to be able to, I don't want to have to say, rather, that, I don't even know if this is even possible, so being able to say something like this, I don't want to do that. I really don't want to do that. So the weird thing, though, I don't need that either. This can go away. The really weird thing about this is that without the L and F, these still come from C. So their types should actually be constrained by the parameter itself. Why they are not, I don't know. Maybe the monad, the type of flat map for maybe the type of flat map for monad is losing some specificity because we're using flat map on the output of these functions. It shouldn't guide the actual types themselves, unless we're running into name collisions. Oh, yeah, because, yes, process args is not a member of that. Oh, and that's why, because process args does not actually, that's disappointing. So it doesn't know. It really doesn't know the type of L and F there. That does make sense. It is regrettable. But I can derive some peace, at least in understanding why it is the way that it is. Definitely don't like it, but there's only so much that can be done. So that isn't so bad, actually, as far as ripping out free goes. I think trying to kind of interleave some of the parameters is going to prove somewhat tricky, but I think if we maintain the same initialization order, if we look at package.scala, if we maintain the same initialization order of these things, so like HTTP .scala, these are already initialized. So if each of these becomes implicit, and then the implementation implicitly uses the other interpreters that have already been instantiated, it should match up. Maybe. think the ors end up just flattening out. And then these aliases flatten out as well. This whole thing goes away, rather, this thing goes away. I don't know how this is going to end up working with this apply. The thing that's getting me stuck is if we look at where we previously did the fold map. So previously we had core args, which is this free f, whatever the type inside the free is, and then we fold map on interpreter. We then, let's look at guardrail runner because that's the thing. Yeah, so we don't need those changes yet. If we look at guardrail runner, the way that this works is we take a map of the language and also the non-empty list of args. We translate that into a target list of paths. This does not actually know about f, which is good. Language to map. And that's not, this is just target, so flat map on target just works. Because the output of this thing is target as well, did I already change this? Let's reset and just look to see. So I haven't even changed this. This is just how it's been. So what I'm trying to do is I'm trying to also maintain what the code looked like before the changes that now compile and what it looks like now. Ooh, core term interp has on line 19 get default framework non-nullery method overrides nullery method. Okay, because I guess core terms oh, cool. Forgot about this. Huh. That'll be useful. This looks like this. So if we inject the logs into program, it just effectively figures out the structure, kind of heuristically intuits what the structure of the free application must be, and then introduces more logs all over the place in order to sort of try to build up what the structure was at the time of construction, which is why we have to explicitly ignore certain function calls by name. It's all hacky, but this allows us to push and pop functions. So as we go into a function, I can just look at it. So as we go into a function, we can push the function's name. So term name extracts the name of the free term. So like case class whatever extends like free blah blah blah. So it extracts the name of that thing, and then we push the fact that we have entered that term. Then we execute we emit a new free structure. So flat mapped suspend allows us to suspend evaluation of A, so basically exactly what we had here. But we suspend that, but then on the F, we actually go into F, emit pop and next. So we emit, I guess we emit the log. What's the, emit is free pure. I don't know why that's there. I don't know. I wonder if inject logs is used somewhere else with a different value. But anyway, we do, it actually works, but it's pretty hacky. I think that we can do better with once the tagless final stuff is done. But the goal is to kind of mass annotate the entire code base with this metadata of how functions are used. Yeah, because that gives us the ability to give really, really detailed debug logs, error logs, and whatnot to people who are trying to use the code generator, but they're running into bugs or anything like that. So it's, with code bases that are this complex, it's important to try to improve those situations wherever we can. So now I don't know why 35. I just full on nuked that stuff, didn't I? Oops. Okay, well, phone's going nuts. I don't know why. Great. Yeah, whatever. Oh, cool. Yeah, so 26 errors is still too high. Didn't this just compile? Didn't I save the file? Did not save the file. So now we will recompile. Later I'm going to run a mile. All right, it worked. So we are once again just going to add all this, grab back. Wow. Deleting, what? I mean, hey, can't argue with that, so that's good. Man, I'm just really not looking forward to doing the next one, because I think this is going to get really hairy very quickly. What we can do is take some inspiration from the change set that we just did to the core term interp. So for instance, if we look at client, so like akka HTTP client, HTTP client generator. So if we don't make any other changes, what we can do is we can say the client term interp extends this function k thing. Now, if we also look at client terms and see that client terms implements all these things, let's see. We're going to need another name. What we can do, I'm trying to sort of get across here, is that we can duplicate this. Oh, actually, that's interesting. Okay, so what I'm thinking is if we get rid of this stuff, let's do down here. So if we say implicit def adapt free, and then we stick that in there. So we've got L is an LA, and we've got F, right? So that's fine. And we return a client terms LF something. But if we don't use F, if we say this F is a G, and instead we are going to emit a client terms free G question mark, what we can do is we can possibly this will be a free in this case. This will go away. Abstract class client terms. These won't have implementations anymore. This is gonna get crazy. All right. That's not what I wanted. I wanted to yank that. I wanted to paste that. I wanted to indent. So this is going to return the client terms free, L free G. So this G is actually free. This is F. Actually, let's flip this. Let's say the F is here. We're still injecting into F client terms free F. Actually, F is what we wanted the whole time. So we've got all of these, free F, all of that stuff, but if we go back up here, we can actually just change, we don't even need to change this F because they're going to be different Fs basically, but we can just nuke these, nuke, nuke, nuke. There we go. We can temporarily inline those, get rid of the trailing equal signs from just this part, actually. And also change the free F into F bracket. So now we have something, client terms looks exactly like it did before. New client terms, this is actually adapt free because we can see that it has the exact same I as before. The I here actually applies to all of the terms inside here, so we have the same implementation of I. Client terms is now, it knows a little bit less about its implementation. So if we look up here, the interface is just an F, but down here the implementation subs in this free F to keep everybody happy, the previous implementation happy, and then we can just get rid of this enum terms. So now we have hopefully adapted enum terms successfully. This may actually work. That'll be really great. It's not going to work at all because we needed, whoa, hey, hold on, calm down there, buddy. Client generator line 39. From Swagger. This get imports coming from client terms. Ooh, but if we, ooh, nice. We can say implicit def client terms monad f is required. We can actually say we need a monad for, let's put that here, because we need a monad for this to work. But because we're actually doing the import underscore in a lot of places, fingers crossed we might actually be able to get it for free. So that would be great. And that's pretty much immediately we're going to start having conflicts. So these are probably going to have different names for the same type, monad f. So we're probably going to want to have a name collision here. Which sucks, but you know, one step at a time. So this will not complain because, okay, yes, for a different reason than I thought. Add. This will complain because we need a 26. We need an implementation for that. Client terms monad is not any. Come on. Is going to be implicit def free. Free monad for free. Sure. Monad free ID, no. Monad free, blah, 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 blah. So we can just grab one of these. Implicit def cats free monad for foldable, nope, nope, nope. Yeah, okay, so free instances, cats free monad for free. Looks good to me. Let's do free, cats free monad for free. See if it works. Man, that'd be cool if it worked. That'd be really awesome. Because that means that we'd be able to actually get a lot of needless churn out of the way and keep the actual commits small. So let's see why it didn't work. Client generator line 59. Generate client operation. This f list definition for required free f. It is though, line 59. So this returns an f of this stuff. This, on the other hand, is a, wait, rendered client operation. This is different. Found list definition, list L definition, and rendered client operation. Required generate client operation. Generate client operation should have worked. Why did it not work? So this is even keeping the same return type of these functions because that just gets swapped in there. So line 59 here, route get parameters. This is also fixing the terms correctly. I hope there's not some sort of collision here. We just try to, so we had 15 errors before, so let's see whether or not we actually still have 15 errors. 11 errors, okay, well that's unfortunate. Oh, but it's actually the same error. Line 59 is the same, yeah, so it's the same error. So that's good. Oh, I think this is actually different than I had anticipated. Wait, by changing that, we get a different response. I don't like that at all. Oh, because the actual instance, aha, good, yes. Client terms will need to be a free f question mark in order to satisfy the constraints. So that makes sense. Good. So the reason that that needed to be that way is because we removed free from the client terms type definition. So we have to match the right instance of client terms. So we can now just go 91. Actually, we don't even have to do that. We can just client terms LF and find maybe. Looks promising. Great. That's actually really great. Okay. Happily adapting client terms to new tagless final interface. And I didn't actually commit anything. Yeah. Great. That's super awesome. This is going to reduce a lot of boilerplate. So given that, now we can go to client term interp and extends function k with these things, which also, function k is a trait, hopefully. And we can also extend client terms in the same object to have Scala language and target with function k. So this is going to hopefully give us stubs, which would be great. If this works, then we will have a really solid plan for doing the migration, which it does, so that's awesome. Man, I really don't want to just copy paste all of those. Let's grab them from here. We also want the monad implicit as well. So we can let's put them down in the actual interpreter area. So we want them close to apply, and we want them in the same order as apply, as they appear rather in the match, in the case match. So, oh no. Route meta is actually exploded. Okay, well, so much for that, I guess. No. Wow, that has a lot of stuff in it. Okay, good. sure enough, let's grab the whole implementation and go to generate client operation and paste the whole implementation. Dent. Now we can stub that. We can generate client operation is going to be here, where instead of actually doing the work, we're just going to say this L target, I think. We don't have any arguments for it. Okay, because it's an F rendered client operation, so it doesn't need any arguments. We are already inside, which means that we are now in a position where we just stick those there. We need to keep what's the first argument to this thing, class name. Great. We do want to val that from route. Okay, so that kind of maintains the intent of the previous function. These need to be suffixed with triple question. This is now fine to just be on one line. This to here, class name, and route meta. Wow, this is exciting. No, monad is not defined here. Okay, so import counts monad. So we should actually see very few changes if we ignore white space. Sure enough, we do, which is great. F is not defined. F is because we have to swap F to be target, since we're running inside target. Yes, 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 yes. Okay, looks good to me. We could do a type alias for F, but I think it would just make the errors more obfuscated. How we do also need to replace L, of course. Let's leave L as an alias. Oh, that sucks because now we don't even have. I don't like that. We're going to have to do like L underscored so that we can have a disambiguated. Actually, that's a question. If I let's do class foo A. Now A is an A. Def no type A is A. Yeah, okay, that's what I expected. So you would need to do A underscore like the, yeah, A underscore. Yeah, so that's unfortunate. Ouch. I don't like it, but if we have to do it in order to preserve sanity, type L is going to just be L underscore. And that lets us do these dereferences without like changing absolutely everything. HB, so security scheme just got imported from here, fine. Route meta was previously not defined either. We didn't need route meta, apparently. Oh, route meta, sorry, imported. Oh, which means that we can just put this here. Oops. We don't need you. One error left. 3 more arguments then can it be applied to create client operation. Create client operation. Generate client operation. So we had previously, the function here actually has the 2 argument lists separated just after parameters. So we can do the same. So we'll, no. Too many arguments for method generate client operation, but that's lowercase because line 369, generate client operation. Oh, come on. 189. It's not though, it's the same. 1, 2, 3, 4. 1, 2, 3. So it's not the same. Okay, you win this time. 1, 2, 3, 4, 5. Whoops. Route method name responses. Did I have a route? This is super confusing. Route method name responses. Oh wow, they're actually in completely different order. Well, that's exciting. Great. Something something hate thinks I hate it. Whatever the appropriate emotion to be feeling right now actually is. So it looks like first argument. Ugh. First argument, then the second one is just route. Route meta is not here. Route meta is route class method name tracing class name tracing security schemas. This is horrible. Class name tracing security schemas. Class name tracing parameters. The route responses. So route method name responses. Route method name responses. And then security schemas goes before parameters. Well, that's exciting. Maybe we can fix that eventually. L is ambiguous. Imported, oh no. Okay. Well, that's at least one way to force my hand to remove this L hack. Okay. Now we can just, oh, we can actually still, get one more L hack under our sleeves. We can say type L is Scala language. Because this is defined outside of client term interp, the C underscore imports, oh, actually even better. We don't even need to do that because we can put it inside because it's not part of the interface for client terms. So we can actually just have this L hanging out here. It's properly scoped inside here, so we're not doing anything really sneaky with external references to types, but it means that we don't have to rewrite all of our all of our references here. So we may still want to in the future, but right now we can just sort of keep the change set small. Previously, these were not referred to by name because they were in the free monad apply function, which has every L fully expanded and also anonymous. So if we look at the case generate client operation, this generate client operation does not actually have any named type arguments. Right? They're all just pattern matches. So the F and L are unspecified here, but they are enforced by the actual apply itself. This is where the L is fixed. This is where the F is fixed. So anyway, this is great. This means that we can actually now do the rest of these. Man, that's super cool. This is really, really, really good. So get imports. We don't need tracing. Okay. Get imports, tracing, target list, blah, blah, blah is just that. Get extra imports. Yes. Get extra imports is, this is like this. Tracing, yep. So paste that there. Get client class args. This client class args is going to be the same as this. Tracing name service URLs, and tracing. This looks good. Whereas the definition of this comes along over here. Awesome. I'm not worried too much about the formatting because we are just going to reformat everything. Keep in mind we are editing the Akka HTTP client generator currently. So, okay. Yep. Operation ID responses protocol LMs, good. So we go over here, we paste that. It's all pure. Anyway, as I was saying, we're just going to run the reformatter once this PR is stabilized. Build static, nope, generate support definitions. This needs tracing and security schemes. We don't do support definitions for Akka HTTP apparently. Yep, sure enough, we don't. Build static defins. Client name, tracing name, server URLs, base path, constructor args. Whoa, there's a lot more parameters there than I expected. Oh, I was reading the next line down. Client name, tracing name, service URLs, constructor args, tracing. Client name, tracing name, server URLs, constructor args, tracing. Okay. I'm trying to make sure that none of the parameter names change when moving these around, because trying to fix that in effectively after all the work has been done would be absolute madness. So here we are with our static defins. Yep. So there's that. Build client is maybe the last one. It is the last one. Great. This is exciting. So we just take that, I did not actually check to see if the parameters were all named the same. I hope they are. I hope they're in the same order. We'll know soon enough. Well, at least they're the same types. I don't know if they're the same order, but we can diff-w. Wow. Great. Good enough. We can look at build client. Actually, here. No, not here. We need to actually grab the real constructor here. So client name, tracing name, server URLs, base path, constructor args, client calls, support definitions, tracing. So they do match up. So that's good. Format, just to avoid so much pain later on. But this is a great first step, actually. Yep. Exactly adapting terms to new TF interface. Only 400 more to go. No, there's only a couple more, I think. Probably 10? Yeah, something like that. But the fact is that by doing this, this is effectively a no-op. The whole apply method is a no-op. Once the implicits are available in the right scopes, and also this monad hack is really awesome. Same with the L hack, actually, the type alias. Yeah, this, oh, and also I did forget to actually implement it, so let's stick this up here. Client, client term, Scala language this, client term. Did I forget to do something? I think I did. No, I didn't. Because this is where the injection happens. Client terms monad. Client terms monad. I don't think this is necessary. Oh, this is necessary because we actually have a distinct monad here for target. Okay, good. That's a relief. So we can actually say this is just target. What's the name of it? Target instances. Don't have any questions, which is great, because it means that now if I say, for instance, if I say implicitly, client term interp, this is one thing, whoops, that because we have client term interp as a non-implicit object, it's not going to be able to implicitly satisfy the requirements for the functions that actually use these things. So if we look for client terms, for instance, client terms as an argument, so this client terms here, this, first of all, requires free. What we'll end up doing is we'll actually propagate free to all of these. until it's in all of the terms, and then we'll just remove the free, flatten these back down to L and F, and then remove the free here as well. And that just in one instant converts these functions from free monads to tagless final without actually requiring any other work, which is going to be really good. And also it doesn't require the, does it? I think that this is not going to require the monad constraint on F, although we may want to go back and add it for sanity and completeness later, but I'm trying to keep the code changes small. The reason we don't need the monad instance for F here is because they would get imported at these sites by importing client terms. Client terms, once again, has this client terms monad here. So by importing the monad instance for the bound F inside here, the flat maps will just start working. We don't actually use monad error in the actual functions, so I don't think that we need a monad error implementation, but we could have one by simply changing this to monad error and F error. That will work, but I don't think that we use that anywhere. If we do, if it turns out that we do, then it's easy enough to add. But we can, I mean, that's great. I'm really happy with this. That's really, really good. I wish there was a Scala fix for this. I think this is going to be really boring to do. But at least it doesn't. At least I don't have to rewrite the whole code base. After doing this a couple of times, maybe I'll come up with some good way to work around it. Looking at going back to the client terms, we can do the exact same thing once again by putting the functions as they are next to the apply method. We can extend client terms, Scala language, and target with function k. We can then, these parameters are going to be out of order, that's correct, but we can pop down here next to the next case. Let's also try to, instead of changing all these F's to target, let's actually do type FA to target A, which may remove the need to explicitly dereference F. So, yeah, but the thing that sucks is going to be case, oops, case, come on. Case generate client operation. So this is unpleasant, having to match these names. So class name, route meta is route meta, no, is it? Just route. Right, so generate client operation also needs the route, no, this is route, yeah. So that explodes the parameters from route meta, which is good. This takes, yeah, class name, tracing is correct. Security schemes, okay. Parameters, okay. Route, okay. Method name, okay. Responses, okay. Now we don't need this. Okay. Did I do something weird? May have. I think that I copied generate URL with params as well. So this was, the very next thing was get imports. I must have taken generate URL with params along for the ride here, because this has no need for it. This goes away. Get imports just goes back to being what it was. That is compile. Is this going to work? Before we compile, let's do square bracket at the end of the line gets square bracket equals triple question. So that gives us the stub definitions for those. Let's see if that works. Oops, sure enough. Security scheme, meta, same thing. 2 errors because it showed up twice, I guess. Yeah, it did. Okay, good. Well, that's relatively exciting. Ooh, 1 error because client terms monad. Okay, yep. Client terms monad is the same definition as before. Put that below. Great. So let's do the rest of these. Get imports. Get extra imports. Client class args. This is going to be tracing name, server URLs, tracing. Tracing name, server URLs, and tracing, and we do that inside there. Generate response definitions. Generate response definitions. Yep. This is going to take population ID, responses, protocol LMs, and be exactly what you would think. It's just a straight up call to HTTP for us helper. Generate support definitions. Yeah. Tracing security schemes. Build static diffs. Build client. This one is the one that sucks, I think. Client name, tracing name, server URLs, base path, constructor args, client calls, support definitions, and tracing. Actually, doesn't suck. Let's just copy, paste with lowercase b. Great. There's actually a chance that that is done. No more unimplemented stuff. Awesome. Really awesome. And reformatted. Formatting looks great. Good job. Awesome. No other objectionable changes. This is going to be client terms. Yeah, okay, so let's just, I'll have to make a new commit for each one of these because it's all the same. There's no point. Commits are free, but at the same time, HBF. So let's look for function k client term. Yep, this is endpoints. Okay, cool. Extends client terms with Scala language, target with that stuff, which means we grab that, we put that there, type f is target a. Great. I'm interested to see if people actually use the endpoints interpreter out in the wild. We added it for Scala.js support internally. It's been pretty good, actually. It's very, very difficult to write, but it's been very stable since then, so I'm happy. Route meta. Yeah, this one's, I just don't learn my lesson here. These are all pretty much copied from the same thing, so I should just blindly trust, but can't bring myself to blindly trust. No. Come on. So disappointing. Metals. Why? Whoa. Take back what I said, Metals. You're great. You should stay. Okay, so we've got all of that. This is just route. This is val. That is route. This goes with me. Okay, cool. I'm likely going to have to step out in a few minutes here to soothe a crying baby. This similarly gets stubbed. Generate clone operation, collapse, get imports. I'm trying to think of if I can do a macro for these. suck. It would be very potentially error prone, so I'm just going to avoid doing that. Get imports. Actually, if the method name itself is on the same line, I guess I could do. So for instance, I could, let's try to write one for this. So if I W that, paste, oh, now I've screwed it up, okay. What I want to do is I want to paste but lowercase. I guess I'm already prim matched, so I could just lowercase this, so. Is there a, whoa. I don't know if there's a lowercase. I am bad at them. Whoa. Get extra imports. Client class args. Generate response definitions. This is not super bad, I guess. Just being able to match the names of the functions directly out of the case class name. That's actually fast enough, I think. I need to be careful not to accidentally kill my clipboard. Build client is the last one. Yeah, sure enough. Oh. I'll kill my clipboard for this. Build client, this, go back to here, this is large, this goes there. Great. Interestingly, I think that's it. Not found monad. Not found security schema. Security scheme. Meta. Yep. And there's the crying. So, oh, yeah, sure enough. Okay, I'll be back in probably about half an hour. All right, somewhat placated, baby. So let's do route. I think the name of the first parameter was operation, not class name. Class name, route method name, tracing, all that. Who knows, really? Let's back over to the. All right, cool. class name route method name tracing. This, on the other hand, that's wrong. All right. Oh, I also forgot to actually take the route, take the implementation of this function from here. So anyway, point is class name route method name tracing parameters. Class name tracing security schema parameters route. Class name tracing security schemas parameters. Class name tracing security stream parameters. Okay, and then that's what it is. I'm sure this was done for a good reason, but class name tracing parameters security schemas. Class name tracing security schema. Security schemas parameters. Route method name responses. Route method name responses. All good. So this. Get imports. So there's that. Get imports. Sure enough, looks good to me. Now, bafflingly, there are imports. Get imports. Tracing. So there's that. We've got get extra imports. With this, that, tracing. Could actually leave the type description on there, but I don't like it. I think it's sloppy. Client class args. Actually, that is something we can do. There's that. Generate response definitions. Generate response definitions looks like this. And then generate oh, wait, hold on. Generate response definitions already exists as a function. That's awesome. Generate response definitions. Oh, because I already put it there. That's what I get for doing things out of order. All right, so we've got that, generate support definitions for all of those things here. Could do this without curlies, actually, as it turns out. This one actually has no support definitions. Build static definitions. Same. Build static definitions. This one also can just be pure. Build client. This one's the beefy one. Build client. Now, down here at the end is where, wow, this is a big method. Target. Great. Build client. Super good. There we go. I'm sure that there are support definitions in here. Yes, of course there are. Okay, good. So, given that, we've now adapted, I think, successfully. Oh, we need the imports. Import cats monad. Route meta needs. Ooh. Security scheme 22 errors found. That's exciting. Class definition not a member of some stuff. Is that true? Is that true? maybe this is Java language. Oh yeah, there you go. Not found Scala parameters. Okay. Why not? All right. Probably defined in core. Oh, in generators. Okay. Guardrail, protocol, generators, Scala parameters. Responses. Terms responses. I don't know why. Oh. So there's that. Responses, strict protocol elms. Strict support, strict protocol elms. All right. Oops. There you go. Format. Well, there you go. Now, I believe that that is the end. We may be able to, maybe the test will even compile, which would be a minor miracle. It didn't even compile tests. Well, that is great. Docs helpers, yeah, totally fine. So we not only have successfully adapted client terms to tagless final structure, but also we did it without making any major changes to the free monadic interpreters. And we've got another crying baby. All right. So, again, it seems like everything largely worked. We maintained free, and it all compiles relatively nicely. The unfortunate aspect to this is that depending on how, I mean, we haven't changed anything. So the merge conflicts for open PRs are going to be relatively manageable, I think. No sense stopping now, I guess. So what I can do is I can push this up. Tagless final part 1. Also, what I should have done is I should have said -re support re base formatting strategies that so second, there's a horrible beeping noise somewhere. That was a, I don't know what that beeping noise was, but it stopped before I could get to it. Last, tag list final part 1. So, I mean, hey, as things go, that's pretty good. I am pleased with how this all turned out. Oh, good. There we go. So, yeah, so this is good. This is getting, what is it, core term and clant, merge conflicts should be fairly minimal. So for adding new parameters to free methods. So, I mean, there's that. I kind of want to continue because there's no reason not to. Let's actually do this. Let's do package Scala. Yeah, so let's do this. Let's grab this, buddy. All right, so we've got, let's edit this thing to include Scala. Let's actually could do even better. Could do rep ho az term L, I think. No, brackets not balanced, of course, because these are swapped. This should have been like this. All right. So, what we want is a checklist of the class names, and we have already done client term. So this as a so there you go. And we got a checklist. So that is great. I think that we've only done client term, so I think that's accurate. Let's do, I mean, Scala term is not so bad, I guess. Oops. Build failed. Why? Why did the build fail? Run tests is wrong for some reason. That's unexpected. Oh, that's actually expected. Okay, so I don't like that it could then test compile should have found that. But apparently it did not. So there you go. Write package back. On 90. Process args we had. Process args. What was the changes did we make? So we passed in the args and we just get the, oh wait, this is implicit core terms C with F. I mean, core term interp is here. Could just pass it directly. Be done with it. Can't argue with that. Not enough arguments for monad and C. Yeah, okay, cool. So I kind of disagree with this now that we actually have a better option. So let's stick monad. Let's stick that inside core terms like we did for the other thing. Ready? Come on. Core terms. Core terms should have a def monad f type monad f. Yeah, we just create one. Now core terms, the implementation of which is where here implicit def monad f monad target instances. So there you go. There's your monad f. Ideally, this should then cause whoa, buddy. We wanted one other thing, which is cats inject down. Yeah. Monad. Take a look at get default flat map is not a member of F. Yeah, it is 180. You're importing C anyway. You've got cats implicits as core terms. Core terms defines a implicit def monad. Sorry, you're right. Core term interp does not have monad. Okay, cats data, cats flat map, monad. Okay, if you say so. I do love removing imports that are unused. Free is now no longer needed. Free. True story. Core term interp, write package back. Core term interp does not exist. Okay. Core term exists. Yeah, that's actually correct as well. So we just new it up, which is great. Means that we don't have to have case class for no reason. Now this belongs in the previous commit. Core term interp, monad f, monad, these changes. Client terms, nope. Core terms. Go over there. Great. We can then move these up there. Sure enough. And also rebase formatting on top of, whoops, that's not what I wanted. Yeah, this is what I wanted, because I realized too late that I had actually final through here. Yeah. I realized that I had not pushed up the branch before trying to actually rebase onto it. So let's push dash F. Actually, we don't even need that. We need just grab this. I think this reference is fine. Bash rebase formatting. That commit, please. Go. So again, rebase formatting is a super useful tool that lives inside the support directory. It interleaves a bunch of Scala format on every single commit. You can't tell once it's done, but you can tell based on the fact that it does not actually have any white space commits. Like if there's no like, oh, formatting, fix up formatting, whatever, as the last commit. So as a result, fewer merge conflicts, easier to move things around. Git blame is not going to have like all of the useful lines that actually Git bisect won't find lines that are just formatting lines or anything like that. Like these, it's generally easier to find stuff when it's structured like this without having a dedicated, like this is the where I'm going to reformat the world in one giant commit. So anyway, my soapbox. But it's just support and then rebase formatting .sh. It's got documentation too. So only 150 lines of bash. .72 lines of bash without comments. So that's good. So, given that, yes, Scala term is the next one that we're going to do. Scala terms. Oh no, this is, oh god. All right. All right. Oh, this is just on its own. That's fine. Okay, cool. So let's do what we did before. New Scala terms on top of free f question mark. Let's do what we did before here, which is implicit def monad f monad. Let's monad. Come on. You disappoint me, metals. Give me monad. Monad f. Fine. I monad. Now this, not necessary. It's already there. These go to the end. Whoops. These go to the end. Like so. These all lose their free. This is kind of fun. Let's actually just do giant regex. And another. There you go. Okay, so we've got what we had before, which is this f, monad f. All of these need to have their free f, comma, to just become f. Yep. Okay. So there's your f on top of those. That should all just continue to match. We are missing a monad f on top of terms, terms, like that, right there. Monad f, okay. So maybe there's no precedent for expecting this to work, but you know, here's hoping. 143. Scala terms, found that, required that is, oh, you're right, actually. Great. That also means that there's one more thing missing here. I had. Come on. I did that. Oh, yeah, you're right. Abstract class. Venting gases. All right. Free required f understand. Fine. Common.scala line 78. So SC should have found it. I'll be honest. Somewhat surprised. 99 errors though. That seems almost like it's too many. I just don't. Let's just do one of them. I just want the first. It's still going to give me about a billion warnings, but maybe I can catch the error. Okay. Found free required f. 78. We've done this before. With prefixes, extract security schemes. What is this? Oh, LLAF. Oh, I was actually inferring correctly. Traverse route, get class name. So get class name, I would think, would be, no, vendor prefixes. That's the one that has this f-list string. Oh, of course, I forgot that Scala terms need to be modified with free f question to adapt it back. So that's going to be required everywhere. Scala terms. F, no. LF, oh no. Oh no. That's quite disappointing. Yeah, let's start. So what I'm looking for while I'm doing these changes is I'm looking to see whether or not any of these Scala terms appear on their own in the parameter list, because any of those methods don't actually need to have this free adapter. They just will magically work. The only reason that we need to do this free adapter is when Scala terms, for instance, is paired with Swagger terms, like in that function, because they need to be the same monad. But so long as they are the same monad, it doesn't matter. That one's been done. This needs to be done. Framework terms as well. It's like, okay, there's only two, so it's very easy to know how to make that change once the once it's been fixed, like changed over. Oh, like this one. This one is great because this one only has Scala terms with L and F, which means instead of, yeah, perfect. So we can actually say this is going to return any F that gets passed in. This is going to be option empty L term. It's the equivalent of none pure F. Probably. I don't like that. Default value is option L term. Oh, option L term pure F. Okay, we just use empty. Yeah, perfect. Free, pure none. Ready, don't care. Empty. Great. Super great. Now this is interesting. The lit string. This lit string comes from. This is actually coming from Scala term, so it's fine. Operation ID, client generator. 31 errors found. Okay, so let's keep it on. Free F. We've got Scala terms here. Scala terms here. Don't need that actually. This can just be. This is also going to be pretty great. It's going to make all of these much simpler, I think, in the end. S vendor prefixes. We don't have. Oh, that sucks. Hey, buddy. Hey, buddy. Hold on. And we may be back. All right. So let's. The one unfortunate aspect of this is that we don't have functor because we're not importing s underscore here. We may need to alter this slightly. We may also be able to do like a low priority implicits thing in order to pull monad out. Let's try that first. Let's do Scala terms. No, because this is already an implicit. So maybe it'll just work. Because the monad instance is in the companion object for Scala terms. So, I don't know, client generator. All right, so, I didn't do it here. Oh, I didn't do it, yeah, because this is fine. right, all right. Just sort of mindlessly doing this at this point because there's only a couple of them left. Okay, parameters. I mean, here's open. Could not find implicit Scala terms. F. 4 errors though, not bad. Protocol generator 489. Scala terms F 489. Hello. That doesn't make any sense. Oh, I know why. Because we probably changed that over to free F question mark, I think. Probably did anyway. That would make sense. Yep. So Swagger util 125. 3 errors left. 125. Map is not a member of that yet, sure enough. But we knew that was going to happen, so at least we were prepared. Not a parameter of F list string, because it's searching for the monad instance in F. It's not going to look in Scala terms for that, so I think that we actually do have to do this, which sucks. So there you go. So we are maybe good. Looks good. We just need to implement Scala terms. Yeah. Extend Scala terms also. What the heck is this? Could not find implicit value for Sparger spec runner. Okay. Line 34. How did this work before then? It was magically finding the instance because of what? What is even being asked here? Cogent application target, function K, cogent application target, Scala terms, cogent application L, Scala terms language. Oh, because we actually don't have one for cogent application L. All we have is for a target. Well, that's an exciting development. Why? Why do we care? What is it? What's even happening here? Scala terms inject into why? F. So this is F. This should be F. Function K. Cogent application L2 T this F to target. Cogent application L is to F, F, F. Oh, maybe. Definitions to F. That fold map framework. Fine, value or this would be F at this point. No, this would be, uh-oh. Because we're actually, yeah, that's why it was structured the way that it was. Because we need to, we're not actually solely based on F, we're based on some other crap with F. Okay, well, whatever. F. Let's just keep on keeping on. Fold map framework at the end of this is going to be an F value or this run empty. Yeah. So here, this is going to make everything very angry, but that's entirely fine because we're going to say L target. Could not find implicit value for that. Yep. I mean, we could actually hardcode this to target, and then we could, might actually make the most sense. Could not find FW framework terms for target. Okay. Framework terms to target. That doesn't make sense. Framework terms to target. This should have framework terms to cogent application going from framework. So that function K is going to compile. Oh, this is into, okay. Watch a man's brain melt out his ears on stream. So we're could not find FW on line 34. FW being here, framework terms, F, because target framework terms, that should totally be there though. Because, oh, maybe not actually, as I realize. Because if we don't have them here, then they just won't be resolved at call time. And so maybe just by stringing them through, we can call target. Oh, but we actually specialize, not specialize, we actually concretize what F is here. So okay, let's look at then another example of extends framework terms. Framework term. Yeah, framework term. Okay, so we want framework terms. New framework term, so server terms is there, given inject framework term into whatever F is, but there is no way to inject it into F because this doesn't make any sense anymore. But what we had before was codegen application L question mark, which did make sense. Codegen application L question mark, fine. Now we did not fold map, we did fold map. Oh, so exhausting. So this is why this was the way that it was. So let's put it back to a known good state. And now with the benefit of having a little bit more thought at it, let's try again. So we are interpreting all of these framework terms, Scala terms, Swagger terms into codegen application. But because what we were just working on was Scala terms still has an implicit Scala term that injects into free f. Could not find value for Scala terms. L, that crap. It should totally be there. I disagree with everything that's going on. 34. Run Swagger. So L given Scala terms. Let's do this then. This is that. Implicitly Scala terms L codegen application L question mark. So that should find this function, provided that L and F, provided that they can actually be inferred. Hope so. That'd be nice. Can't, that's not nice. What about if we look at, oh, that might be why actually, because this is actually free F question mark. That's why. There you go. Not found type free. Perfect. Cats, implicits, import cats free. So the reason that that was necessary is because Scala terms, this is F. We need free F in order to match framework terms' type signature of expecting, no, Scala terms, expecting that F is inside free here. So, down to one error, Sparta background from line 89. That's because similarly, Scala terms here, colon Q, free F question mark. So there's that. We can actually just do those swaps for empty to start. Oops. Well. I just passed right by it. Oh, no, I didn't. Good. So no, yes. Yes, yes. Great. Wow, that's awesome. All right, cool. So Scala terms is also rolling. And we just straight up got rid of some calls in the vendor extensions file. We actually just, there's no free there at all anymore, which is pretty awesome. Okay. Moving the white space there. Why is there so much white space? Fully qualified package name. Lookup format, embed, or bed, parse pure method parameter is with type names equal. Okay, good. This is that, and a bunch of crap. So that's great too. Oops. There you go. Need that. Okay, cool. Commit, Scala terms. So there's that. Don't need those. So that's pretty great. Let's do can we, yeah, okay, base shy. Could actually do that in, yeah, whatever. Get base -I upstream master. Duplicate, and there's that. Is there? Yeah, so that's fine. Switch quick train to take the final. Yeah, so there you go. Yep. Calculate updating Scala terms, client terms. Wait, hold on. So this is name only, and that's client terms. Yeah, well, good. So Scala terms now actually does have its own completely separate thing, which means that this can be extends that with that. This is Java Lang and target. So here we are with these things. We've got, this isn't what I wanted actually, was it? No, I wanted that. Oh, I've angered somebody, I don't know who. Yeah, that's fair. It's okay to be upset. Name imports definition. Name D3 D3F underscore, no C3, no C2F underscore. Name, what was it? What? Name imports definitions. Name imports definitions. So that that, that, wrap, go there, there. Okay. Almost forgot that this needs to have a type F. A is target A. Type L is Java language. Okay, so here you go. First one converted. Vendor prefixes. Vendor prefixes. So there's that. Lit string value. There's that. Lit float. Yep. Okay. Lit double. Okay. Lit int. Wow, this is boring. Lit long. Lit boolean. Lift optional type. No, you did the wrong thing. Lift optional type. Value. Okay. Lift optional term. Value. Empty array. Whoa. This has a lot of excitement for an empty array function. Okay. There you go. Empty map. Great. Never stops. Lift vector type. Wait, that's wrong. Empty optional term. Where's that? Just totally skipped over that one because there's no other place. So there's that. Lift vector type. So that's that, that, left, that, lift vector term. No. Yep, sure enough. Lift map type. Okay. Fully qualified package name. Yep. Sucks. Just goes on. Yeah, but what? This is I just want to write a thing. Do I want a linter or a rewrite? I want a rewrite. Yep. Yeah, well, we've been here before. Okay, well, worst case, whoa, hey. So I'm in the guardrail repo right now. So no Scalafix repo guardrail. Who knows if this is the right thing to do? Sure, at the very least, going to be more interesting than doing all this stuff by hand. Because then we have to do it for all interpreters for all sets of terms. So, good to automate. Okay, template applied in that. Okay, fine, so Scalafix. SBT tests. Test. Yeah. Repository, some stuff. Template generate Scalafix for rules. Contain that. Input, output. Fine. Scalafix to this. Great. I don't care about IntelliJ. But I don't care about this. I want, yep, I know about that. Okay, so import the build right into this one. Use by matching. So this is not at all dismissing the value of this documentation. I just know how to use Scala Moda already. I just want to check run rule from source code. This is exactly what I want. Scalafix, rules, file, blah, blah, blah. I don't have the Scalafix binary. I don't have that at all. How do I get one? Oh, well, that's another thing. So, SPT Scalafix, search.maven.org, SPT Scalafix. 093, this is totally different. EPFL Scala, yeah. What's the difference between these two things? Okay. No. SBT. Test. Let's try again. And I've been doing this now for almost 4 hours. Oh, nope, just a little bit over 4 hours. So once the test pass here, I think I'm going to call it quits for today. So thanks for hanging out. Next time, I'm trying to figure out how to use Scalafix. Oh, it passed. Well, there you go. Let's actually try one thing, which is everything is committed. How to get Scalafix binary installation. Something. That's totally reasonable. Oh, yeah, look at that. CLI, Scalafix, great. Perfect, I'm fine with that. So let's stick that. Bootstrap something, 2.12.4 fine 0913. I think is the version of Scalafix that I care about. Then 0913, yeah. That. Fine. Looks good to me. No, of course not. Of course not. Let's look. Scalafix CLI. Fine. That, yeah. Scalafix CLI. Oh. There's no CLI. Okay, good. Whew. 2.12.8. 0.96. What the hell? How has it not been released? 0.93. Scalafix CLI. This is not a CLI option anymore. How are you supposed to run this thing? Tool, class path, run Scalafix, permanently install. The rule for build users can have the dependency to build SPT. I don't need that. I don't want to publish. I just want to run it. Using GitHub, using file. Okay, well, you know what? Let's just install an old version of Scalafix. 0.96. It's also not right because this is needs to be 2.12.8. There we go. Chug. So let's rules. Rule suite. Fix v1 rule. Guardrail, tree sure, why not? Okay, override fix, semantic document patch, tree syntax patch empty. Okay. What's a .rule file? Scala fix. Local bin. Scala fix. Let's move that to move local bin, Scala fix, tools. Localized bin, Scala fix. Do you run? Scala fix rules, something, 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 path to named literal arguments. Great. Zeesh, tab completion, bash tab completion. Wow, that's cool. Okay, so rules file to can I just run this thing? Oh no, do I have to run this one? No. This is probably the one to run. Maybe. No. No such file exception. That's actually true. So fix /rules. That's much better. Again, I'm sure that, oh no. I'm sure that Scala fix is definitely the tool for the job. Just need to spend some time thinking about it. So with that, signing off. So we ended up getting, you know, one of them done at least. So we got 4 and then it's like 5, so you know, 9 left. So some of them are actually pretty small. So like a new protocol term model, protocol support term, those probably only have like 5 or so methods each. Server term and Scala term and framework and Swagger, they have, you know, 15, 30, and then additionally we have to worry about converting all of the stubs for all of the different implementations, and then also it would be nice to release the Scala fix rule set as a module that other people can use to, hey buddy. Anyway, point is, be nice to release the Scala fix rules for this change so that anyone who has an internal fork of guardrail, like we have an internal fork, not really a fork so much as an extension on top of the existing guardrail interpreters. So being able to supply a Scala fix rule that just does the conversion for even internal repositories would be, I think, probably the right thing to do, even though it looks like it's going to be a little bit more work to do the research into how to use Scala fix effectively. So I'll watch a YouTube tutorial, if any exist, on it before the next stream. So anyway, with that, thanks for hanging out, and see you maybe tomorrow. Later.